Hey kiddos, welcome to Chem 30. Welcome to you guys out there, not in my class, and I'm teaching in an empty classroom. So it's kind of awkward for me, but I'm envisioning you that you guys are here, you're engaged, you're looking at me, you're nodding, and we're going to do this. So this is our first part of electrochemistry. Up until now, when we balanced equations, we just looked at the entities we balanced. Everything was great. But what we have to realize, though, is that now we're actually looking at where electrons move. Where are they going? Are they being um, gained or are they being lost? So now, more importantly than ever, we're taking a look at the movement of electrons. So just to take a look at historical terms of reduction and oxidation. Those two terms we're going to be using for the duration of the unit. Reduction back in the day was the process of producing metals from their compounds, and oxidation back in the day was a process of a substance reacting with oxygen. Um, any kind of oxidation reaction were examples like corrosion, so the formation of rust, and a simple combustion reaction, those are considered oxidation. Now what we're doing is we're taking a look at what oxidization or oxidizing and reducing actually means. If you take a look over here, we have sodium metal and we have chlorine gas. If you take a look at those are, well, here, for example, we have a solid and here we have a gas. These are neutral substances. The protons and the electrons are equal. If we break this down, we get NaCl, no big deal, that's your salt. If I put this in water, it's going to break down into sodium ion, right? And chlorine gas, or chloride ion, I should say. If you take a look at this now, things are different. Something went on. All of a sudden, we're taking a look at sodium metal can easily turn into sodium ion. So what happened? What's going on? How did this positive, where did that come from? Did sodium here, did it lose or did it gain an electron to have a positive charge? Well, it lost an electron. So because it lost an electron, all of a sudden chemists are like, let's look into this a little bit more. Chlorine, on the other hand, Cl2 gas, if in this case here, it moved to chloride ion, in water, in the presence of water, what happened here? How did something neutral all of a sudden have a negative charge? Well, it gained an electron. So this losing of electrons and gaining of electrons, that's what spurred our new understanding of oxidation and reduction. So here, sodium lost an electron, so it's oxidized. That's what we think now. Oxidization is the loss of electrons. Chlorine gained an electron, so we say that it was reduced. Reduction, kiddos, means gain of electron. And why the term reduction? Because if you think about it, if you're gaining electrons, if you think about it in the numerical sense, you're actually the number is getting smaller because it's getting more negative, it's reduced. I don't know if that helps. Moving on, here we have just an idea of how we show reduction and oxidation. Again, with the same example, we have chlorine gas. Because it got this little negative charge here, we say that it gained electrons. Why 2? Why is there a 2 here? Because it gained 1 electron. This is like saying there's 2 chlorines. Okay, 1 electron here. It gained 1 electron to become a Cl minus. It gained 1 electron here to become Cl minus. So that's where the 2 comes from because it's for each of the chlorines. So shows the chlorine is gaining 2 electrons. And here we have sodium losing an electron. What you don't do ever is you can't subtract an electron, you can only add electrons. So it has to be on the product side. If you are losing electrons, it shows up on the product side. If you're gaining electrons, it shows up on the reactant side. So here's an example of how to memorize that. If you think of oil rig, oxidation is loss of electrons and reduction is gain of electrons. Or Leo the lion says grr, I'm sure you've heard that before. Loss of electrons is oxidization and gain of electrons is reduction. So here's an example of a reaction, and this reaction here we can break it down. Remember back in the day in Chem 20 when we learned about uh, just doing net ionic equations and we had the spectator ions and disappeared. So this example here is looking at the two things that are going on. In this case here, sodium has to gain an electron to go from sodium ion to sodium metal. And in this example here, calcium has to lose 2 electrons to go from calcium solid to calcium 2 plus. It actually lost 2 electrons. Losing electrons is oxidation. Gaining electrons is reduction. What happens to the NO3? These are spectator ions. They're not actually part of the reaction. We cancel those out. That's why they disappear. That's why they're not there. Here, we call this the electron transfer theory. So here's an example of a single replacement reaction with zinc with hydrochloric acid. It's balanced. It forms zinc chloride plus hydrogen gas. Awesome. If we take a look at a half reaction, represents what is happening to one reactant in an overall reaction. It shows either a loss or gain of electrons by a substance. Any of these guys, any of these equations is going to have an oxidation half reaction and a reduction half reaction. We call those redox. So let's take a look at what happens. Zinc loses 2 electrons to have a +2 charge. And in this case here, 2 hydrogen ions gain an electron each for a total of 2 electrons to form hydrogen gas. This charge, you have to gain an electron, 2 of them, 1 for each hydrogen, to make this neutral, because here there's no charge. So it had to become neutral. Here's another example of a reaction. We have sodium plus chlorine gas yields sodium chloride. So what we're going to do is we're going to break down into 2 reactions. We're going to start off with the oxidation reaction, which is a loss. So we have sodium metal. And what I like to do sometimes is leave a blank so that I can think about what is going on in order to go from neutral to a plus charge. Did it gain an electron or did it lose an electron? Well, it had to lose an electron to go from a neutral to a +1, and 1 electron had to be lost. For the reduction one, we're going to go Cl2 plus, I'm going to leave a little space, 2Cl minus. It's 2Cl minus, I just went ahead and did that because there are 2 chlorines. So in order to go from something neutral to something that's negative charge, what had to happen? Did you have to gain electrons or lose electrons? Well, we had to gain electrons. We actually had to gain 2 electrons in order for that to happen. Now take a look, kiddos. If I wanted to add this up together, we'll notice that there are electrons on the reactant side and there's electrons on the product side. We're going to learn right away, but in order to make this a redox reaction, we have to just make sure that the number of electrons are balanced so I can get rid of them. So here's 1 electron here. There's 2 electrons here. That's no bueno. I have to multiply all of this by 2 so that there's 2 electrons, right? Now my electrons can cancel out. And if I were to add this together, it'd be 2Na solid, right, plus Cl2 gas yields 2Na plus 2Cl minus. So this is our new fancy way of balancing. I know, it's kind of fun. But your homework shows little baby steps and just looking at what is reduction, what is oxidation, are you gaining electrons, are you losing electrons, and then it moves on from there. Here's another example. We have sodium, silver nitrate reacts with copper to form copper nitrate and silver. Let's take a look at a gain of electrons. It's called reduction because you're gaining electrons. It's called reduction. Here's my gain of electrons. I have a positive charge. This is neutral. In order for a positive charge to go away, to become neutral, I have to gain an electron. And a loss of electrons is called oxidation. I have a solid here, it's neutral. So really what that means, it has a charge of 0. To go from 0 to +2, I would have to have lost 2 electrons. Okay? Again, sodium nitrate is a spectator ion, so we don't include it. And almost done with this part, kiddos. In any redox reaction, which is a reduction and oxidation reaction, the total number of electrons gained in a reaction must equal the total number of electrons lost. So the electrons gained must equal electrons lost. So here's an example. We're going to write balanced half reactions for copper metal with aqueous silver nitrate. So we have our copper metal, our silver nitrate is going to yield copper nitrate plus silver. Basically what's happening here is, because notice how this is NO3 and it's in a compound, it's NO3 minus, right? This is also NO3 minus. They're the same, so they go away. So here's my first one. We're talking about copper. Goes from copper, which is neutral, to copper 2 plus. What had to happen? You had to have lost 2 electrons to make that happen. A loss of electrons is oxidation. And here we have a gain of 2 electrons because we have a 2 plus here, right? And we have to have neutral here. The reason why there's 2 kiddos is because there's 2 here. So we have to make sure that these match. So this is reduction. If you add these up together, you'll notice that there's 2 electrons in the reactant side, 2 electrons on the product side. They cancel out. And here is your balanced equation. The new way of balancing an equation. Not so much like Chem 20, but you know, the more we know, the more we know we don't know. Here's another example. Write and label 2 balanced half reaction equations to describe the reaction of zinc metal with aqueous lead 2 nitrate. So here we go. Zinc solid, it's a single replacement reaction with lead nitrate, lead 2 nitrate. The nitrate is NO3 minus and NO3 minus, they cancel out. So here's our first one. Zinc solid turns into zinc 2 plus. In order to go from neutral to a charge of +2, we had to have lost 2 electrons. So loss of electrons is what, kiddos? Oxidation. Here we have to gain. So here we have to gain. We have a lead 2 plus. In order to become neutral, we have to gain 2 electrons. A gain is reduction. A gain of electrons is reduction. Reduction. Okay, and that's it. Let's take a look at a summary. A redox reaction is a chemical reaction in which electrons are transferred between entities. The total number of electrons gained in the reduction equals the total number of electrons lost in oxidation. Reduction is the process in which electrons are gained. Oxidation, electrons are lost. And both reduction and oxidation are represented by half reactions. So take a few minutes, take a break, and I will see you soon.